Okay, so let's start with that. We're going to present ourselves. François Xavier? No, I cannot pronounce it.
You shall pronounce it FX. Everyone
FX.
does it.
FX. FX. I learned French, but I cannot say your name. Do you want to present yourself?
You want me to say my name? Yeah, okay, I can. François Xavier.
Okay, he's the product manager for BCI and everything related. So everything we talk about containers, BCI, and all the evolution of BCI, just blame him. That's the thing. And then we have Daniel Run. That's
yeah.
You can say your name too.
You said my name very well. So your German seems to be better than your French.
Yes. Ich habe eine Decke. That's the only thing I know in German. German people don't ask why. Okay, and I'm Sergio Ocon. If you're Spanish, Sergio Ocon. If you're not, don't try. Sergio is okay. It's like his name. Nobody can pronounce it. I know you know, I hope you know, that we have made a couple of changes in the last months, weeks in the SUSE portfolio. One of them is that we're moving into a new code base that we call it Framework 1. So every time you see Framework 1, we are talking about the new code base. And also we have released SLE Micro 6.0 that is an immutable system. And SLE Micro is part of Rancher, is part of Edge. So if you have used Rancher, you have used Edge, and in Rancher you have used the operating system that you can use with that. You are actually using already SLE Micro. But now one of the big changes, small changes we're doing is we are productizing that for every single place. We think there's a strong position for using SLE Micro outside of embedded system, Rancher, Edge, or anything that basically the operator system is there, but you don't see it. And one of the things is it's an immutable system. And when there's an immutable system, why would you use an immutable system after 25 years of SUSE where everything was working in the way it should? And if you've been here, I see a lot of heads like mine with less hair than expected. So you've been here for a few years, and you already know how to do this. You know how to work. Why would you go to a different place? And we're trying to convince you because it's a good idea. And immutable system has one thing, they're immutable, so you cannot use an application directory. You need containers on top. So we're going to talk a little about what is good and what is bad about using an immutable system, specifically to run containers. And of course, if you are using Rancher, most of the things we're going to say doesn't apply to you because the operating system is hidden, but it still is below, and still you benefit from all those things, and still are good things that you're going to have. So we are going to go through this. I will try not to bore you with agendas, but the slide was here, and I'm following the template. So I will start with that. And this is actually a reality. All the analysts says that what you really want is Kubernetes. They said the same a few times before, so OpenStack was there, and before another thing, and before another thing, and before another. But from the mainframes to Linux on all the operating system, what we have is different stacks with different places. And every time you move from one to the other, you need to learn new things. We were talking about salt, or whatever you say it, in the previous session. Ansible and Salt, using Ansible and Salt means you need to learn how to use Ansible and Salt. There's different concepts from running traditional Linux. You want to automate, you need to start thinking of that. But also when you move into containers, half of you already are using containers. Your application doesn't work. It does work sometimes, but you need to change your processes, you need to change the way you do. If you are using rootless container, you have enjoyed the pains of running containers in production. It breaks. And security and 12-factor apps. I used to have a hobby application built on Elixir, and the funny thing about that is it stores the variables when you compile. So it was working in every single step, and then in production wasn't working because the actual variable I was using was created 3 steps before. And until you learn that, this is really a very it's a complex way to do it. It's not so many things, but you need to be very careful. And then you move to Kubernetes, and everything's gone. The Kubernetes API is amazing. You need orchestration. You need anything that it gives you, and it's magic. It works. But that also means you need to learn what is a service and how you create the load balancers so your service is found in there. And you need to create your containers and your pods. And well, if you're using some kind of fabric, you need to put something in your container to run the fabric. And then you need to create the storage and the number of replicas and the health checks and. And what we see in the market is when you go to this place, you no longer are a sysadmin. You are an application app SRE, or you are a platform engineer, or whatever new thing they created this week. Because it's complex, and it's really good, but it also means you need different people, and you go to the market, and not everybody knows how to use Kubernetes or has. I saw yesterday an ad, they were asking for 15 years of experience in Kubernetes for a thing that is really nice, because 2 weeks ago it was 10 years old, and it's already people saying, well, you need 15 to work in this company. So this is great, but it's not the end thing. So what we are saying now, it's things like application collection, rancher application collection, where you start to say, okay, let's put all together. Either you're running one host or you're running a cluster. Let's put all together and start giving you container native application. And we also seeing that from different partners, where they start to, you are required to use some kind of containers because the way they deploy application is container. And that's really good. And there's a lot of good things about that. And we're also seeing the other side is this is still a need for a lot of traditional work. And we're in SUSE. We've been doing this for a lot of years. We're very, very good at doing secure applications, secure dependencies. So we're working on that. And actually, how we see the world, and most of it because the European Union is asking for it, and because the US is asking for it, is we see that as a content. You have content, you have an application, you need to have the components, and then choose what is the best way of deploying your application. You're traditional because your application cannot be refactored. That's okay. We will help you. You need to have containers. You need to have a Helm chart or anything. We also gonna be there to provide what you need. And at the end, that's gonna help you because it's not a question of what is your preferred platform. It's the question of what is the preferred way to run your application, and that depends on the application. It doesn't depend on what is the last trend in the market and what is cool today. Because I'm pretty sure next year we will be talking about WebAssembly and how WebAssembly is gonna destroy the world and change everything, and nothing else is coming in. At least this time, WebAssembly is running on Kubernetes, so we will still have Kubernetes below. But just to sum up, what that means that you need to have a lot of things in your mind. And you want to go from the left to the right, so everything is complex and you have tools for everything, different thing, and go to a place where everything is shiny and works and you don't really need to go think. And one of the things of immutable system is that it's working to put you into this state that things fix themselves and things work because they have to work. They don't work because you are constantly overlooking what they're doing. And of course, that means that you care for all of this, but many of the capabilities of this are built on that. If just going quickly, developers, specifically in Cloud Native, have a requirement for the last version, just 2 minutes after it's released. So if you have Go, it has to be the latest Go. But then you go to traditional systems, and you want stability. You want to make sure that you don't have any CVE or some XS bug that you didn't discover. So you need a process, not just the upstream code, but you also need to know how that has been done. And the same for the configuration drift. Anybody that has run more than one system know that many of your systems are not in the state you want to have. I had a friend that was working with me in a company. They were basically I was working in a company and they tried to rebuild our network. And it was a telco operator, so there has a lot of network there. And then they have to stop because they found like 20-something routers that have configuration that was not stored, and they couldn't find why that configuration was there. Somebody has gone into routers in a telco company and changed the configuration manually. And then when they tried to change it, they were saying, no, you cannot reboot it because it's not stored in memory. You cannot change it because we don't know why it's there, and we risk to lose money if you reboot that. That's what I'm talking when I'm talking configuration drift. You have to have that in mind. This is always going to be a different well, what you have in mind and what's actually there. The same for security vulnerabilities or updates where it basically breaks and you do an update, it shouldn't be doing anything wrong, and suddenly your system is not booting anymore. And I know all of us has worked with a system that happened to that. I've seen that in Kubernetes a lot. I've been working many years as a product manager for Kubernetes. And well, there was a 20% of chance of making a system upgrade and losing your cluster. Some things will not boot because it's complex. And I think it's way better now, but that's something you have to have in mind when you're doing that. And of course, everything that's happening with confidential compute, supply chain security, and all the other regulatory requirements that happen in the US and in Europe specifically. So let's talk about immutable. We come here to talk about immutable, and I'm going to talk about immutable. And when you talk about immutable, again, you're not talking about immutable. Immutable can be referred as a system that cannot be changed, and if you have a phone, that's basically your phone. You install a new image of the operating system to be able to change it. That's great. But it's also something that some companies are trying to put into the host and the operating system itself. If you cannot change it, you're going to avoid a lot of problems. It also introduces new problems, like changing your password, because if the system is immutable, you're not going to be changing your etc password file, and then you don't have a new password. And that implies some changes. And we've been working a lot of that. And actually, Slim Micro, it's immutable, but we're doing some adjustment on top to make sure it's not that. Also, some people call immutable when they say declarative. When they want to say declarative, they say immutable. And basically, declarative is what Kubernetes does. It's I define what is my state. I want this system to be at this state. The system magically changes things to do that. And that's not new. That's not Kubernetes only. When we were having Puppet basically worked on that concept. But if you think of that, Puppet was really nice to use. I've used it. It's really nice to use until you had to do something complex, and then you didn't know what's going on. So how do we find an equilibrium between being declarative and not being a mess? It's something also we're working on. And it's very related to immutable because something called declarative immutable. Of course, if you need to change a declarative system, you change the declaration, the definition of the system, so you don't touch the system itself. But there still is a different concept that you need to have in mind. And then we have transactional. And transactional systems are those where you basically all the changes are in a transaction, so you can roll back. Really, really important, because rolling back allows you to go to a known state that is working. So if you break something, it will work. No more undefined state, no more friends leaving routers untouched because they don't know what to do. In an immutable system, that cannot happen because every change you do is basically done from within a transaction. And then after the transaction will be applied or it will roll back. But there's nothing in the middle. There's no inconsistent state in the middle. And of course, lately, another definition that I don't find right of immutable is reproducible. If I want to have a copy of my system, how I do that? And I will tell you, that's not as easy as it sounds, because if you have IDs or you have names, you want to have your subscription, of course you are here, so you have SUSE subscriptions. those are dependent on your system. So reproducing your system is not copying the hard drive and putting in another system. You actually need to know what you're doing. And all of that, all of this, it's what we call immutable, and this is actually what you want to have when you're having an immutable system. And if you go to the market, you will find no system in the market is covering all of this. Some of them are covering one side, some of them are covering another. We will cover that. Just come to SUSECON next year and you will see a lot of advancement in this solution. But why should you care? Anybody so far has said, I want an immutable system in my life and I cannot leave this SUSECON without an immutable system? Any hand? No? You can. Great. Oh, thank you. Thank you. But let's work. Why we need that? First, because of security. If I have a system that is small, because my application is not running directory, it's more secure. It can be leaner, it can be smaller, and it can be updated faster. One of the things that happened with that is SUSE has around 10,000 packages. SUSE is less. Every time we update one package, we need to make sure the other 9,999 packages need to be compatible with that. Because you can install almost every packet together with any other package. Well, of course your RPM can say, I cannot install this other package because the two emails or two web servers are not compatible, they clash. But everything else should be co-installable. If you reduce that and you make it really, really, really small, you can be very, very secure because you can make sure that you are not installing things. Another thing that happened to us, I talked to a customer a few weeks back and he was telling me, every time you update, we basically, because our certification are so strong, we need to test every single package that you have. And if your email moot client, I don't know if you have used moot in your command line. I'm old, I want to say that. But if you have used moot in your time, well, moot can be old. And somebody forgot to update to the latest SSL library, you can fail a certification. One way of avoiding this is using an immutable system because we can make it really, really strong. Yes, keeping those 1,000 packages. How many are in SLI Micro? 1,000?
A bit more. Yeah, meanwhile a bit more, like 1,500.
1,500. It still sounds like a lot. Yeah, it undermines my speech. Don't listen to him.
I will explain the details.
Yeah, but all the dependencies and all the things you need to build it are there, so there's not so much. And then it simplifies the way of getting high certification, and we do want to have them. You know, SUSE is only one of the only Linux providers in the world that has all the criteria for certification. We work really strong to have EL4 plus.
EL4 plus, yes.
It's hard to say. And so having that also allows you to have attestation and SBOM. That is something you're going to be needing really, really quick because the European Union is asking for that. So you can tell everybody what you have installed, when did you install it, and from where you install it. Of course, having this security has a problem, that is that you need new tools. Because many of the tools you use, many of the integration tools you use, the processes, they will not work anymore. You need to adjust. And one of the things is, because I was saying you, because your immutable system doesn't allow you to work in change things as you wish, there are many tools that don't expect that. So they will go and change the host name, modify an etc host name, and if you have an immutable system, that will not fly. So you need to change the way you do things. So be careful with that. Again, we talk about so many things that it doesn't matter, but it's there. The second thing is, again, what I was telling before. This allows reliability to be very high. Because if you have a transactional system, you can always come back in time. And there's a way to do that. If you have an image-based system, you can have two images normally. A, B, and you start with one, you start with another. I used to have a lot of hardware that has the A/B mode, so you have two firmware that you can change. That's not so common anyway, lately, in the things I buy, not so expensive. But in an immutable system, you can actually have more than one version. So if you discover that you messed it up 2 weeks ago, well, depending on your policy, you can go back to that. And that allows that to go and work everything, because you always have a version to go back and run with the configuration. Not only the packages, but all of the configuration. That's one piece missing there. That is health checks. So you need to have an automated way of testing that your system is behaving. And if you have it, when it's easy, you check, it fails, you go back. You want to see this and how this works. There's a lab tomorrow. I'm also part of it. I won't talk so much. There's another person doing the demo and the tutorial. So come, because you won't suffer so much. But you will see this in real life, how this is work. And because it's immutable, everything is there, booting, and that's one of the drawbacks of this, you have to boot to change the configuration. But booting is not the expensive zipper update that downloads a few packages, then uncompress them, install them, change it, and reboot. It's just rebooting. Everything else can be done before you start, and that's really, really good for us. And of course, there's another thing there, another drawback, because your content is a container, you need to have the container. You need to manage the container independently, something that FX is going to be talking. And I'm looking at the time, and I'm going to be faster and talk a little less. Okay, more things that happen. Of course, because you have an immutable system or you have a declarative system, it's really easy to get a snapshot. It's really easy to update. Most of the work is done easier. It's done before you actually updates. And that allows you to be very, very efficient, because if you are deploying the same thing to a different system, you can start thinking of processes improvement, and you can start working easier on the things. And of course, again, we come back to the same thing, because we have a snapshot is not unsafe. You know, somebody told me yesterday, having dinner, about the critical patch paradox. That is your most critical system, because it cannot be rebooted. It's basically the last one, the one that you don't update so often, because you cannot afford to reboot it. So you keep it as good as you can, but that means you need to find a window to update, and it's not so easy. This kind of system basically allows you to separate the container from the OS. So we are working on ways of making you update the system, has the latest version, use the more secure environment you can without needing to go to the pain of that long 30 minutes reboot that was needed in the past. And the other part also is, of course, if you have an image, and that's applied specifically to declarative system, it's hard to adapt. Image-based systems are really great. You can deploy it really easily, but then one of the things that happen to you is that if you start to have a very complex system, and I've seen that a lot in edge cases where one has GPUs, the other one has another hardware, another is different, you basically run out of options. And I'm looking at no question asked so far. I will ask you to interrupt me as much as you can, because I'm talking too much and I don't have water with me.
And if I may add, if you have a question, just briefly raise your hand and I'll get you the microphone.
Okay. So just going, just finalizing this part, I'm going to talk a little about scalability. And it's also, well, you've seen it. If you have Edge, you have Rancher, you know about the scalability, and that's one of the reasons they use an immutable system below. But one of the things, it's because it's very lean, it has a very reduced overhead. It also allows to implement all the performance that you can. Because you are replicating a system and you are copying the configuration, you can dedicate time to update one system, and you can dedicate time to make sure that system is optimized for your use case, and then it is really easy to copy the configuration to the other 1,000 systems. And before, if every system is different and its own child, it's really difficult to apply the same optimization for all of them. But in these cases, we're talking about being able to re-engineer and work on that. In some cases, of course, that means making use of the new system or Kubernetes or any orchestration system, and that requires your application to be rebuilt to get use of all of that. But in many cases, you can basically go and do what you need to make sure that your system is working as good as it can with your tools. And lastly, if you have any CI/CD process, you are already needing to use container. So when immutable system that runs container, you can basically reuse the infrastructure components, all your pipeline. Develop on a system that is running in a container, and then for QA, test, everything can run in the same operating system that is running your container in the same way. So you're basically making really easy to avoid the complexity of making production as close to your development as you expect. And there's one piece of that is that you need to be aware is that when you're using container, you're using any operating system that is not certified. Thinking of Alpine, because most of the tutorials in the internet use Alpine. Just look at the number of CVEs that Alpine has. You're using that image, you're having a problem in production. You don't know because you are using the latest version of that, but they are not actually secure, they are not actually reviewed and updated as you need. If you have any liability, if you have requirements for compliance, that's something to be very careful because it can mess up your production environment easily. So I'm going to stop talking and I'm going to pass the thing to FX.
Thank you. So yeah, we're going to talk about the challenges that goes with this kind of operating system. First thing, it's not your typical operating system. It's a real project to migrate to this kind of operating system. It can be complex. It can require to adapt your processes, your tool. You may need to embrace new practices. You need to train your team. There are a lot of consequences in migrating to those operating systems. So we really want you to be cognizant of that because as many technology improvements, it requires to be taken seriously. Especially if you want to scale, if you want to embrace the capability of immutable small operating system, as you would expect in the edge environment, in the cloud environment, etc. Bear in mind, it's something you need to address as well. The implementation may require automation, may require version control, so that's something serious. But at the same time, it brings a lot of value. That's why we really motivate you to try it. One aspect is that it relies on containers or virtual machines. But let's focus on containers today. You will see that a lot of content available for containers may have some different profile in terms of security or certification, reliability, etc., compared to what you used to consume as RPM. So that's also one of the challenges of immutable systems. And if you want to focus specifically on the development aspects, and of course, migration to container, adoption of containers brings a lot of value for developers, and it's super cool because you don't have to take care about difference between production environment and development environment. You don't have to take care of the different Linux system on which it can run, etc., etc. It's really simplified the work of developers. It simplified the work of ISV that don't necessarily have to certify on several operating systems. It brings a lot of value, but it comes with challenges. And one of them is related to the way people consume open source components in the container world compared to traditionally. If you look back 5 years ago when you didn't necessarily use containers, when you needed, as a developer, an open source component, you would zipper install it. And without even bearing attention to that, you would actually download it from your operating system vendor. What it means is that it would have the same characteristic as the operating system, the same quality of the build, the same guarantee, very often the same life cycle, and it's also included in the scope of things that are supported on production with your subscription to your OS. In the container world, because it's all about empowering developers to download things, the containers, and manage their environment themselves, it also means that you may have 10 teams of developers, and all of them are using different containers for different open source applications. And those containers may not come with the same security postures, the same certifications, the same supportability characteristics, etc. And therefore, you have a challenge in aligning on best practices. And that's a question that you need to ask before migrating toward this kind of universe. How am I going to be sure that everything I'm going to put in production or everything I'm going to put into something I'm going to ship or sell is going to align on the same best practices that I have to be aligned to? So that's need for alignment on best practices. Then enterprise lifecycle and supportability. In a sense, developer adoption, container adoption, is very much a developer-driven movement, as opposed to an operating system vendor-driven movement, or an operation-driven movement. And developers and operations don't necessarily have the same focus, and of course, operations care about supportability. Developers not that much at the beginning of the project, at least. And so we end up with a landscape of applications containerized out there that may not have supportability, or that they can be supported on production, but only on vertically aligned stack. Or you can have supportability, but the meaning of supportability of the application A is not exactly the same as the meaning of supportability from the provider of the application B, etc., etc. Getting away of this world where most of your open source components were consumed from your OS vendor is creating this scattered landscape in terms of supportability. And then you have the risk avoidance. Sergio touched on this a little bit. There are many regulations that are coming both in Europe and in the US. In Europe, we have a Cyber Resilience Act, we have the Digital Operation Resilience Act, we have Product Liability Directive, we have Network Infrastructure Security Directive. In US, you have everything related to secure software development framework. We have many things coming that basically all share the same paradigm, which is, first of all, everyone shall be aware and liable for everything it ships and sells, or run. So as a company that runs IT or ship IT, if you're an ISV, you would be liable with everything, for everything, and not just the bits you developed yourself. And secondly, you are responsible for ensuring that all the supply chain of all your providers is good enough and meets the requirements of the regulations. So that's very important in the context of containers, because containers are black boxes. When you download the Apache container from somewhere, or the Nginx or whatever, you focus on the workload, the workload like Apache, Nginx, or MariaDB, whatever. But it's not just that. The container contains between 50 to 100 packages. And who has built them? Who is liable for them? Who is securing them? How can we be reassured that all the precautions have been made in order to be sure that things were not tampered with? These are the questions you should ask yourself when you're dealing with containers, because those regulations may make it your liability. And so those three challenges we see related to using containers in development: alignment and best practices, enterprise lifecycle, and supportability. And how do you avoid the risk related to compliance and liability? And we have responses.
Yeah, thank you, FX. So if you let me come through. Thanks, Sergio. So, how do I put it? Now that we've heard about the reality and the future, let me take a step back and briefly look a bit more at the past. Let me start to talk about how did we, based on what Sergio and FX described and the feedback of customers, come to SUSE Linux Enterprise Micro as implementation. And I'm very proud that we have Richard Brown here, one of the brains behind that architecture. So I'll stay away as much as possible from the technical parts as a product manager. I ask you, so if you want to have some more details on the technical part, I think a good advice is to sponsor him a drink and get some stories. The PM view on how we get or got to the product is a bit different potentially. So when we had the technology basically in-house already, based on what Sergio and FX already explained, we were thinking how to productize it. And the first thing we did was actually go from customer to customer and partner to partner. Talk to them about what we have in our development queue, ask them what would be the requirements currently and going forward. What are they going to do? And specifically when we talk about containerization, we back then talked about digital transformation, etc. And essentially, and some of you may recall I had a session on that at SuseCon, the overall feedback could be summarized in, I don't want to care about the OS, I need the OS to be stable and take care of itself. Right, so and we called it the invisible OS last year. Yeah, but when you drill down in what is required to do that, then you basically, in SliMicro, you have a small footprint operating system. And the small, yes, we have 1,500 packages. But that's the amount of packages that we have in the product repository, right? That's not the amount of packages that are installed on the target image. We just provide, as SuseCon says, choice. So choice happens at the customer. The customer really modifies SliMicro to the intended use case and finds the required packages in our repositories. The installed operating system is again pretty small when you compare it to general purpose operating systems. Now, Sergio already explained the immutable part, right? So basically an operating system that is not modified during runtime as a default. The immutability, however, only applies to the core parts of the operating system. It's very important to understand there are writable parts on the disk, right? So it's not that everything is read-only and you cannot write anything. Basically, I used to explain to customers what SUSE provides to you, that's immutable. That's under read-only. What you install, you can put it into a writable directly, but you can also put it into the immutable part. So number one, we have the small footprint enterprise-grade operating system. Enterprise-grade because we did not create new packages. We did not create a new kernel. We take what we have in SUSE Linux Enterprise, which is well known, which is, as FX explained, covered by the certifications, including our development processes and the maintenance processes, and package it into a tailor-made, optimized solution for containerization and virtualization workloads. With that, you get to the mission-critical feature of SUSE Linux Enterprise Micro, right? You have the stable packages, you have the stability of the operating system that come with these packages, you have the SUSE support that supports you. So that's the second pillar. In addition to that, we introduced actually already a longer life cycle with SliMicro. So we offer 4 years of general support compared to other offerings that have a shorter life cycle. The product actually can give you more than the 4 years. So far, I have to be very honest, we haven't productized that because we haven't seen a big customer demand on that. So if you are in a situation where you require more than 4 years of general support for your operating system, then just talk to us. We'll find a solution. At the moment, that hasn't been the case yet. The third pillar, based on the customer feedback, and I hinted at that, is really low maintenance. I always say SliMicro's goal is to go towards zero maintenance and administration. So the goal of SliMicro is that you deploy the operating system once and then forget about it because it takes care of itself. And the way we've implemented that, Sergio already hinted at that, with the health checks, we have the immutable operating system based on snapshots. So if something goes wrong, the system can roll back itself automatically. And if you want to see how that works, please join us at our demo booth in the technology showcase later on. The operating system can install updates itself automatically and reboot itself to activate them automatically at given times, etc. So the goal for the operating system really is to take the administration and maintenance overhead away from humans. So the humans can concentrate on working on the workloads, on the containers, actually on the level where you generate your added value towards your customers. And lastly, we've tuned that system really for container and virtual machine workloads. The focus here is on container workloads. We have a container runtime that is not Kubernetes as a default, but SliMicro, when you look at our Edge solution or Ranger Friends, is usually being used within a Kubernetes environment. We support it fully in both. We actually also support it with a third-party Kubernetes distribution, but I think it's understandable that our preference is on the Ranger Kubernetes distributions.
Yeah, we trust them more.
Understandably, right? So, briefly looking at as an overview in the context of time. So, we explained that a lot. So, we have a transactional system with rollback, meaning we have a read-only file system. Updates or package changes are installed onto that system within one transaction. That transaction means, okay, create a writable copy of my running operating system, install all the packages and apply all changes that I want to happen into that writable snapshot, and then verify the return code of that operation. If the return code is okay, then this snapshot is marked as a new snapshot for the new operating system boot. And if that error code indicates an issue, either during package installation or configuration change, then that snapshot is actually automatically thrown away and an error is logged. Right? This can be configured to be automatic. Actually, I think our default configuration is for that to be automatic every night. But sometimes you may end up in a situation that after installing updates and rebooting the system, it may not come up. It's more likely to happen when somebody manually interacts with the operating system, to be very frank and honest, doing some configuration changes that shouldn't have been done, or removing or adding packages that may not be installed on the target system due to its setup. Our solution for that is a health check that Sergio already hinted at. It's a small daemon that you can extend, so you can customize it to your workload. And that health check daemon, when the operating system starts, will check automatically whether the services it expects come up, and if not, then it will act based on the configuration. We provide a default configuration that first tries to restart the service, then restart the operating system, and if both fail, then it will roll back to a previous known snapshot automatically without any interaction. Again, for this one, you can have a demo in the technology showcase today.
And there's a tutorial tomorrow where we will try to break a SliMicro system for 50 minutes. I'm pretty sure we won't succeed. I hope.
I have more trust in you. Immutability, let's be realistic. It's not the golden solution for security, right? So immutable systems can be broken. They just offer you a higher level of reliability. So let's be realistic. Let's continue just quickly. In an immutable operating system, so meaning you're running from a read-only root file system. When everything is read-only, you cannot apply configuration changes. And even when using Kubernetes, you need to change configuration on the operating system. The way we implemented it is with an overlay file system for /etc. So you can actually create and modify files in there. And the transactional update functionality that we use to update the system to a new level actually keeps those changes in the overlay file system consistent with a snapshot. So whenever you need to roll back your system, the configuration changes will be consistent with a snapshot. That's really important because the package updates may introduce a new configuration file format that is incompatible to an older version. Right? So if we only rolled back the package and not the configuration, then you'd end up in a broken system and then again have to send out a service technician. That's exactly what we want to avoid here, right? So the operating system shall take care of itself. Just a few words.
Yeah, we have 5 minutes.
Sergio, you're talking too much.
I know. I'm sorry.
His fault.
Sorry.
Always his fault.
Just a few highlights. So SLI Micro 6.0 that we are announcing at SUSECON here is ready for confidential computing. However, there's a limitation to it. So we fully support SLI Micro as a confidential compute guest in the public cloud. We do not yet support SLI Micro as a confidential compute virtualization host. That is going to come with one of the next releases. Tentatively, I'd say with version 6.2 to be released next year. Right, so just for everybody to understand, in the public cloud, as a VM, as a guest, you can use SLI Micro and confidential compute setups. As a host, that's not available yet. If you attend the SUSE Linux Enterprise Server roadmap, you will learn that there, with 15 SP6, it's a technology preview. The difference between server and micro here is that, to be very open, I'm trying to stay away from technology previews in micro. The operating system is very small and very focused on a specific use case. And I'd rather like to only provide production-ready features to my customers here. Right? So that's not saying anything bad about SUSE Linux Enterprise Server, but the difference between micro and server is micro is really focused on container host and virtualization host. Enterprise Server is a general purpose operating system where we can introduce technology previews easier. I'll come to you.
I have to say that I'm a little bit confused because a lot of information is missing. For example, how to install RKE2? Usually this is just a curl command. In your world, it must be a package installation, no? The curl command runs? Okay, and how to install containers using Helm?
Excellent question, by the way, thank you. So, as I said, read-only on SLI Micro are only the parts of the operating system that we deliver, right? So there are writable parts. And K3S or RKE2, via the curl-based deployment, just install fine. Because they install into a writable area of the operating system, so they do not install into the immutable part. Right? And deploying containers is the same depending on the container runtime you're using. So you use Podman, then you use Podman commands to pull the containers from the registry and start them. If you use Kubernetes, then you either use it manually or you use Helm charts. Yes, of course. So. So the question was just for the recording whether we are limited to immutable containers or not. No. So the response is, as I said, only the operating system is immutable. The rest works just fine. You don't see any change to your operations when you use RKE2 or any other Kubernetes distribution or container runtime on SLI Micro. There's nothing you need to take care of. You just operate normally. With the benefit of having the immutable transactional operating system underneath that takes care of itself. You're welcome. Good. I will just wrap it up with one statement, and that's important. We provide a real-time kernel option with SLI Micro out of the box, so it's not an additional add-on, etc. So you have, as a customer and partner, the choice whether you want to run the default kernel or a real-time kernel. On that one, real-time is limited to 64-bit Intel AMD systems at the moment, and 64-bit ARM support is coming, same as confidential compute host support with one of the next releases and being worked on. If you have an interest in real-time on ARM, then please let us know, because we may have the opportunity to get you into the testing round for that kernel. So, and with that, I hand back to FX. And sorry for the time constraint.
Yes, so...
you have 1 minute.
I have 1 minute, so it's really easy. It's made to be presented in 1 minute. You'll have this content presented a little bit more deeply in the roadmap on Linux. I don't think we have time to go through that, but there are very, very interesting aspects that we're going to cover for the roadmap on Linux. And I also want to draw your attention to the security and compliance discussion. We have something on Wednesday, special security in the container world, where we're going to tell you all about that and in detail, and you'd be very happy, I guess. And we wanted to give you a little bit glimpse in the future, but we don't necessarily have time either. So please join us at the presentation of the roadmap for Linux. Just be aware we have something in mind for the future of SleepBCI, which will address many of the which should improve the value offering we have on top of that.
Yeah.
And I'm sure you'll be happy to hear about that. But
Because
we'll
I
have time to-
like full houses. Wednesday, there's the roadmap where we will be talking about Sleep Micro and BCI and the new containers and all the new things that are coming to containers. And you can come and see us again. I promise I will speak less in the next two presentations, so you can come and see me quiet. That is really hard for me, but I will do it for you. So, it's the time we need to go, but if you have any question, we will be in the booth and we will be around. Just ask us anything you want. We want to know for you how you use container and what are actually your challenges right now with containers. We know they are, because we want to make sure that next SUSECon, you're one of the ones presenting with us saying, this is amazing, I love it, and we are deploying on it. And for that, we need your input. So come to us, let's work together, and thank you for coming.
Have a good day. Thank you.